This video will complete the plate cam translating follower by entering and seeing the geometry for that cam. We're going to enter the geometry for this plate cam translating roller follower, and to do that, first we want to go to the help and go to the tutorials and the plate cam translating follower, and then scroll down till you find the geometry, which is down here a little ways, and it's right there. We're going to enter the data for a plate cam, and it's going to be, as you see this picture, there's a form in the Docs in the Cam Designer SE folder that has a word form like you see on the screen. And this is entered as is filled out with the dimensions we're going to use for this tutorial. Another thing to be aware of is that you have to enter at least one of the segments in kinematics before you can open the geometry form. Once you've done that, you can either use the button for geometry or the geometry in the menu to open the geometry form. And that'll be blank, as you see now. We're going to design, this is a plate cam. It's a translating roller follower. That's all we have available. And it's going to be a face cam, and we're going to be using an inside face. We could use an outside face, that would be pulling. This is going to be pushing. The base radius, as you can see in the help, is going to be 1.75 inches. Cam thickness is 1/2 inch. The diameter of the follower is 5/8 or 0.625. The follower width is going to be 0.375. Sorry, it's going to be 0.5. Cutter diameter, we don't really have to worry about that, but we'll just make it 1/2 inch. Contact width is going to be 1/2 inch. Now the stem angle, that is going to be the angle based on the x-axis being the horizontal axis pointing to the right. And that stem angle is going to be 90 degrees. The offset will, right now we're just going to say it's going to be a radial follower, so it's going to be 0 offset. And right now we're going to leave the follower loads as they are, and we'll just hit the drawing for the cam, and you see that it is going to check the data that we've entered. It says we haven't entered any speed, so we have to do that, and it'll highlight, or it'll go to where the speed has to be entered. We're just going to say that's going to be 60 RPM, and we'll now be able to compute the cam, and we'll click the drawing button. That will compute the cam and give us the drawing of the cam. And you can see that's going to be a 3-dimensional cam. The data that we've entered so far in the geometry will give us the drawing of the cam. It will not show us anything about the dynamics of the cam. It won't give us anything about the stress or the torque it takes to turn it or the power that it would take to turn this cam. We're going to need to enter some loads for that computation to take place. If we go back to the help file, you can see that I have a spring rate in this form of 75 pounds per inch, and I have a preload of 10 pounds. So we can enter that here in the follower loads. If we enter 75 there, and then we put in 10 there. We're going to leave the damper at 0. We're going to leave the follower preload at 0. And we're going to use, for the follower mass, it's going to be 25 pounds. And that's pounds mass. Those are the loads now that we're going to have on this cam. Now if we look at this drawing again, you can see down at the bottom I have cam position, displacement, velocity, and these computed values. As I animate this cam, you'll see that those values now are shown as they're computed. You can see the contact stress, the normal force, torque, etc. Now if you look down here at the output, if we look at the summary, it's going to show us the maximum pressure angle, it's going to show us the radius of curvature, minimum, maximum, and some various summary items that have been computed for this cam. We could look at the tabular, and that'll show us the table of values that have been computed. And we can select, with this output selection, you can select what you want to see in the output that is computed for this cam. You can select all of them if you'd like, or you can pare it down to what you want. When we look at the graph, we can see the values that have been plotted, and these are what's selected in the graph setup that we go over in another video. If you look at the tabular and graph, and then if we go here to this drop down and select, let's say, the radius of curvature, and we look at the minimum radius of curvature, it's going to show us where that occurs. And again, if we turn on the track line, it's going to show us if that's plotted on that graph, which in this case it isn't. It would show us where that occurs as a line on the graph. If I look at the pressure angle, and I know that's plotted, and I select the maximum for that with the track line turned on, it'll show us where that occurs. It shows us up here the position of the cam where that happens and the value. The last thing that we need to do here is make sure that this geometry has been saved. If you notice over here with the cam list, the geo is unnamed. So that says we have not saved the geometry for this cam. To do that, we do the same thing we did with the kinematics. We go to Save As, and we save this. Let's say it's going to be plate, cam, translating, and click the Save button. And now you can see that in the cam list, that name is there on the geometry. And we know then that it's been saved. The last thing we need to do, and this has not been done yet, is to save this cam. We've saved the geometry and the kinematics, but we've not saved the cam. So to do that, we go to Save Cam As, and we do the same thing. And that is the completion of this tutorial. Thanks for watching. For more information, visit www.delta-eng.com.